All right, so excuse me, this is part 3 of your Earth's history exam. Okay, this is going to be the short answer portion, so we have fewer questions, but you have to come up with the answers on your own. Okay. So for number 1, it says base your answer to the following questions on the paragraph below, which provides background information regarding recent fossil discoveries in Canada. Scientific evidence indicates that the earliest mammals may have evolved approximately 225 million years ago from an ancient reptile group called the therapsids. For millions of years afterwards, early mammal and therapsids coexisted until the therapsids apparently became extinct 165 million years ago. However, geologists have recently found a fossil they believe to be a therapsid that is only 60 million years old. They found the fossil, which they have named Chronophorates paradoxus, paradoxical time wanderer, near Calgary in Canada. This find suggests that for 105 million years after the apparent extinction of the therapsids, a few of the reptiles continued to live in a narrow geographic range in Canada. So, state one method geologists could have used to determine that Chronophorates paradoxus lived 60 million years ago. So what you need to do is think about what are some ways we know how to date items or figure out how old they are, and then name one and write that down. Some ways we can date items, figure out how old they are. Number 2, it says base your answer to the following questions on the generalized cross-section of the Grand Canyon represented below and your knowledge of Earth science. Some rock layers have been labeled. The rock layers have not been overturned. So it says, state the approximate age of the red wall limestone in million years. So I circled where the red wall limestone is. You can see what time period that was developed. And then go ahead and look at page 8 of your reference table and figure out how many millions of years old that time period was. How many millions of years ago? Number 3 says, base your answer to the following questions on the diagram below and your knowledge of Earth science. The diagrams represent drill core samples from 2 different locations, 1 and 2. A drill core is a cylinder of rock material removed from the bedrock. Letters A through J represent different rock layers, and some layers contain index fossils. The rock layers shown have not been overturned. So it says, list the relative ages of rock layers D, E, F, and G by listing the letters from oldest to youngest. So look at any clues that you can find in these drawings. I'm seeing time period labeled, I'm seeing index fossils, okay? So now you need to give me the relative ages. About how old is D, so D dash, how old is it? How old is E? Look at it, it's even labeled here. F and G. How old are they? Number 4 says base your answer to the following questions on the cross-section below, which shows a portion of the Earth's crust. Letters A through J represent rock units or geologic structures. The rock units have not been overturned. So describe one piece of evidence shown in the cross-section that suggests that rock D is older than F. So we have this intrusion F coming in here. Okay, we have some contact metamorphism around it. But then look at where D is. How do we know that that's younger, that was deposited more recently than this igneous intrusion? Number 5, base your answer to the following questions on the diagram below, which represents a model of the radioactive decay of a particular element. The diagram below shows the decay of a radioactive element, the white, into the stable decay element, the dark, after one half-life period. So you see that you have the original material, it's all that white, and then after the half-life period, it's only 50% of the white and 50% of this decay element. So on the diagram below, shade in the amount of stable decay element present after the second half-life period. Okay, so don't let this trick you. Okay, I've included a little chart here. So we've got 2 half-lives have elapsed. Okay, we know what percentage of the radioactive element remains. That's going to be the white part. What you need to put on here is how much of that stable decay element remains. We know that it all has to add up to 100%, right? So show me how much of that dark stable decay element remains. Should be more than the radioactive element. Number 6 says base your answer to the following questions on the table of index fossils shown below in your knowledge of earth science. Complete the classification table by filling in the general fossil group name for each index fossil. So I've labeled what these are in your reference table. So we have Y, G, and C. So on page 9 in the reference tables, look at the line on which you can find the letter representing each index fossil. So you'll see an up and down vertical line. And you'll see that index fossil on that line. Look at the line, and that'll tell you the group that you can find that index fossil in. Okay, number 7 is going to be based on all these maps. I'm just going to kind of swing through these. This shows you New York, and then map C is going to be on the next page, and that's Long Island. Map B is this area in Oswego. I don't think you actually need that for the question. You don't. But map C is going to be this area on Long Island. Here we are. This is Long Island, this darker part. We're going to be talking about this Harbor Hill Moraine. Okay. So it says, the drawing below shows a glacial erratic found on the beach of the north shore of Long Island near the Harbor Hill Moraine. So just what it showed you there. This boulder is composed of 1 billion-year-old gneiss. Okay. These maps aren't as important as this information. Which New York State landscape region has a surface bedrock similar in age to this erratic? So we know that this is 1 billion years old. Okay, and it is gneiss. Oh, for some reason I can't see that. It is gneiss. So look at pages 2 and 3. I think specifically page 3. You're going to look to see where on the map can you find bedrock composed of gneiss. And then once you find that in New York State, I want you to look back up at the map on the top and tell me what landscape region is that gneiss in. Okay. Number 8 says base your answer to the following questions on this geologic cross-section. The rock layers have not been overturned. Describe one piece of evidence from the cross-section that supports the inference that the fault is older than the basalt intrusion. So we have a fault here. Okay, and then we have this basalt intrusion going on right here. So what do you see in the picture that proves that this fault line is older, was there first before this basalt intrusion? Number 9. Base your answer to the following question from the diagrams below, which represent 2 bedrock outcrops, 1 and 2, found several kilometers apart in New York State. Rock layers are lettered A through F. Drawings represent specific index fossils. During which geologic time period was rock layer C deposited? Okay, so use the index fossil that you see in rock layer C and figure out during what geologic time period was rock layer C deposited. Number 10 says base your answer to the following questions on the cross-section below. Letters A through H represent rock units in which overturning has not occurred. Rock unit B contains fossils of Centroceras, while rock unit F contains fossils of Tetragraptus. Identify one geologic time period when rock unit D could have formed. Okay, so we know that since it's below rock unit B, Okay, that it has to be older than the Centroceras that they found in this rock layer, which is index fossil F. But it's got to be newer than this Tetragraptus, okay, which is index fossil J. So what time period would be between Centroceras and Tetragraptus? Index fossil F and index fossil J. Okay, base your answer to the following questions on the diagrams below, which represent two bedrock outcrops, 1 and 2, found several kilometers apart in New York State. Rock layers are lettered A through F, and drawings represent specific index fossils. So describe one characteristic a fossil must have in order to be considered a good index fossil. What makes something a good index fossil? Think about where it's found. What do we know about it? Okay, why do we use these specific fossils? What makes them special? Number 12, the table below shows information about Earth's geologic history. Letter X represents information that's been omitted. Identify one important geologic event that occurred in New York State that could be placed in the box at X. So look at pages 8 and 9. Okay, figure out one geologic event that occurred that could be placed in box X. Okay, so look at the time period, how many millions of years ago, index fossil. Number 13, base your answer to the following questions on the diagram below, which represent two bedrock outcrops, 1 and 2, found several kilometers apart in New York State. Rock layers are lettered A through F, and drawings represent specific index fossils. Keep seeing this one. Explain why carbon-14 cannot be used to find the geologic age of these index fossils. Remember, C14 can only be used to date things up to 50,000 years old. So maybe give me some information about the ages of these index fossils and tell me why I cannot use carbon-14 for these guys. Number 14. Base your answers to the following questions on the block diagram below and your knowledge of earth science. The diagram represents an igneous intrusion that's solidified between some layers of sedimentary rock. Letter X represents an index fossil in a sedimentary rock layer. The rock layers have not been overturned. The igneous intrusion contains the radioactive isotope potassium-40, which is used in radioactive dating to determine the age of rocks. State one property of potassium-40 that allows it to be useful in the radioactive dating of rocks. Why do we like the radioactive isotopes that we use for dating? What is special about them? This keeps coming up. Why do we use them? Number 15, base your answer to the following question on the geologic cross-section below and your knowledge of earth science. The cross-section shows New York State index fossils and rock layers that have not been overturned. Rock unit A is an igneous intrusion and XY represents an unconformity. So identify the coral index fossil that would most likely be found in the same layer as the index fossil Centrocrineus. Yes, whatever. So use pages 8 and 9 to figure out the time period in which you would find this Centrocrineus, whatever. And what other index fossil might you find around that time? That's your answer. Okay. So if you need to look at any of the ones we went over, scroll back.